Hello, everyone, and welcome to another homework help video. This video is going to continue the series of videos that we've been doing on section 4.5. So let me at this time share the screen and show you the problem that we're going to work on here. This is our second problem, and it says, in a company, there are 7 executives, 4 women and 3 men. 3 are selected to attend a management seminar. Find these probabilities. Okay, so we have 4 different probabilities that we're needing to find here. Okay, so this is a 4-part problem. All right, 7 executives, 4 women and 3 men. 3 are selected to attend a management seminar. Find these probabilities. All 3 who are selected will be women. So let's do this. We're going to take a couple of notes here for the sake of my screen share. So we have this is problem 2, and we have 7 executives. And those 7 executives are divided into 4 women and 3 men. Okay, 4 women and 3 men. Okay. Now, one thing to remember about this, no matter how you do it, is if you're selecting from the whole group, you select from the 7. If you select only women, you have to select women from the women, okay? Not the whole group. You have to select men from men. That seems obvious, but you'd be surprised how many times students make a mistake there. So be careful with that. Now, let's go back to where we were and see what we want to do here. So I'm going to, this is the homework once again. So the first probability says all 3 selected will be women. All 3 will be women. So here, I'm going to say this. I'm going to say that remember our basic way, our basic probability, okay? It's the probability of some event is equal to the number of ways for the event to occur, right? Over the total number of possibilities in the sample space, total number of outcomes in the sample, right? So we have to ask ourselves, what is my event? Well, here, my event is basically choosing 3 women to be on the committee, right? Choosing all women to be on the committee. So here's what we're going to do. I'm going to use combinations for this. So just to make it match our previous work. So I'm looking for the number of ways to choose 3 women to be on the committee out of the total number of ways to choose 3 people. Okay, that might be tricky. The number of ways in the sample space, I'm choosing 3 people. They don't all have to be women. I want to find the probability that if I choose 3 people, that they'll all be women. And I want to find, so here, my S here consists of choosing 3 executives, okay? The number of ways to choose 3 executives. What that means is that when I write my probability, this is part A, the probability of choosing 3 women, right? What I'm going to do is I'm going to say, okay, choosing 3 women is equal to the number of ways to choose 3 women to be on the committee. So I have the probability of from 4. Now, how many women do I have? I have 4. So I'm going to say this. I'm going to say from 4, because there's 4 women, right? I'm going to choose 3 because I only need 3 women on the committee. So 4 choose 3, right? And then I'm going to say that how many executives do I have? I have 7. Choose 3. 7 choose 3. So 4 choose 3, 7 choose 3. Be careful not to cancel, okay? These are combinations, so don't cancel the subscripts. So let's do this, all right? So we have, let's go to our share screen here. We get 4 math, probability, NCR. 4 choose 3, that's 4, okay? Yes, you can put this in all at once, but I want you to see the numbers. 7, math, probability, 3, and we're choosing 3 people, 35. So this becomes 4 out of 35, which is 0.1143. And I think you understand that this doesn't reduce because 4 and 35 don't have a number that goes into both of them other than 1. So this is your initial fraction. It's also your reduced fraction here. So this first part of the question is, let's scroll down. This is question 2. We have 4 out of 35. Okay, so that's our first answer. So now we can say that, let's go to our share screen. We get, this is, remember, we want to practice turning this into a, this is 4, and this is 35. So I'm going to up here, and I'm going to say that this 4 out of 35, right? And this is point, we said that this was, let's see, we said that this came out to be 0.1143. So this answer is equal to this answer is equal to 0.1143, which is equal to 11.43%. Okay. Now keep in mind we have some other parts. So let me do the next part here. I'm going to shift my screen to the second part. We're doing all three selected will be men. Okay, so this time I want 3 men on my committee. So very similar. Here, I'm going to choose 3 men. So in this case, I'm going to say that this is part B, and I'm going to say that I'm going to probability of choosing 3 men, choosing 3 men is going to equal now. From the men, I have to choose men. So here, I'm not going to choose from the 4 women. I'm going to choose from the 3 men. So I'm going to say this. I'm going to say 3. Whoops. There it is. I'm going to say 3. From the 3 men, choose 3 men. From the 3 men, choose 3 men. And again, from the 7 women, sorry, from the 7 executives, choose 3. So 7, choose 3. Okay, now we already know what 7 choose 3 is because we did that before, right? Let's go back to the calculator and calculate this. So now I'm going to say this. I'm going to say, remember my new numerator is 3, math, probability, 3, enter. Whoops. What did I do? Oh, I didn't put a number. That'll do it. 3 choose 3 is 1. There's one way to do that, which makes sense. You're choosing all 3 men. There's only one way to choose all 3 men, which is to take all 3 of them, right? So 3 choose 3 is 1. And as we saw, 7 choose 3 is 35. So here you get 1 out of 35. And again, it doesn't reduce, but I'm going to 1 divided by 35. This is equal to 0.0286. So now I'm going to say this. I'm going to say that this is let me show you here. So this was part B of number 2, and we get 1 out of 35. Okay. So we're going to have the following. This is one out of 35. And we said that this was 0.0286, which we said is equal to 2.86%. So that's part A and part B of this question so far. Now I'm going to go on and do the next 2 parts. Okay, same scenario, 7 executives, 4 women, 3 men. All right. So here we're going to say same scenario, but let's look at part C for this. So part C of the question is, let me go back. Part C of the question is 2 men and 1 woman. 2 men and 1 woman will be selected. So here, okay, so part C is, let me write us a couple of notes for this. So this is, we have 7 executives, right? And we have 4 men and 3 women still. Now, here, part C, we're looking at the probability of choosing 2 men. I believe it was 2 men, was it not? 2 men and 1 woman, or 2 women and a man. Let's see. I don't remember which part was which. So let me go back and look at it. This is 2 men and 1 woman. Okay. 2 men and 1 woman. So here, we're going to say this. We're going to say probability of choosing 2 men and 1 woman. Okay. Now, this is a little bit harder. We have 2 groups, obviously, right? So we have to do, now, we're going to look at the numerator and the denominator separately, because as you remember, this is equal to the number of ways to choose 2 men and 1 woman divided by the number of ways to choose 3 executives. Okay. So we know the bottom, but I'm going to write it in here. Okay. This is the number of ways to choose 3 executives, right? So here we go. Got that. Now, how do I choose 2 men and 1 woman? Well, if you remember from the counting exercises in 4-4, okay, we're going to say that the number of ways to choose 2 men and 1 woman is going to equal the following. So we have, this is going to equal, let me move it over some. There we go. This is going to be from the women, we choose, from the men, which, you know what? I wrote this backwards. Let me fix this because this is wrong. This should be 7 executives. And I'll show you in a second. This is, I haven't done anything wrong here, but I wrote this wrong at the top. 7 executives, there's 4 women and 3 men. Okay, so here I've got 4 women and 3 men. So now from the men, which are 3 men, I choose 2. So this is going to be 3. So this is going to be this. It's going to be 3. Choose 2. Okay. 3, choose 2. 3, choose 2. So there's my, from the 3 men, choose 2 men. And remember, and here means multiply. So I'm just going to make it an X. So it's a little more prominent. But 3, choose 2. And from the women, which is 4, I do 4, choose 1. Okay, 4, choose 1. So 3, choose 2 times 4, choose 1 over the number of ways to choose 3 executives. And we've done that before. So I'm just going to write this in. This is 7, choose 3. Okay, so now I'm going to go and I'm going to put these numbers in the calculator. Make sure you understand where these are coming from. This first group is men. So if 3 men, we choose 2 of them. From the 4 women, we choose 1. So let's go back and let's do this. We have, here we get, this is 4. Again, you can do this all at the same time. I'm doing it individually so you can see the individual result. Math probability in CR3. Now, I'm doing, sorry, this should be 3, choose 2 at this point, right? So let me do 3, choose 2. I could do 4, choose 1 first, but let me do 3, choose 2. 3, choose 2 is 3, okay? 4, choose 1 for math probability and CR1 here. 4, choose 1 is 4. So I have this. I have the following. I have 4, choose 1 is 4. So this is going to give me 3, choose 2. This is 3. And 4, choose 1 is 4. So I have 3 times 4. That's a dot on the screen if you can't see that quite prominently enough, but it is a dot there. I want to multiply it. And I'm going to 7, choose 3 we've done before. I'm going to spare us that calculation again. This is 35. So I have 12. So this becomes 12. This is 12. Not 13. 12, not 11. There we go. 12 out of 35. So that's our fraction. And that's our probability. And again, we can get a decimal and a percentage from that. So let's go back to the calculator and finish this. So here we have, we're going to do 12 over 35.3429. Okay, so we get, this is equal to 0. I'm going to bring this down a bit. There we go. This is equal to 0.3429, which is equal to 34.29%. And so that is how we do that part. And part D is very similar to that. Part D just reverses the number of people. So part D, we have this. We have the probability of choosing one man and two women. Okay, one man and two women. Two women. So now I'm going to say this. Remember, you have to choose men from men and women from women. So here, I'm going to say I'm choosing one man. So from how many men? I have three. So I'm going to say, all right, this is 3. Choose one, right? 3, choose one. Times, because it's and again. So and means multiply. So and here, this is time. And then I'm going to do from the 4 women, I'm going to choose 2. So this is 4, choose 2. 3, choose 1, and 4, choose 2. Over the number of ways there are to get 3 executives. So here, this is going to be 7. The bottom is going to be 7. Choose 3. We're choosing 3 executives. So here, let's go back to the calculator now. We have 3, choose 1. And that should be a 3 down here. Yeah, that's a little easier to see that. All right, so now, let's go to the calculator and work this out. So we have the following. We have 3, math, probability, NCR. 3, choose 1, which is 3. And we have 4 from the 4 women, we choose 2. So math, probability, NCR, number 3, choose 2. 4, choose 2 is 6. So here I get, I'm going to go back to the screen. So I have 3, choose 1. This is equal to the following. So I get equals. And on top, I get 3 times 3 times 6. Okay, this is 6. And then the bottom, I get, oops, let me use the line. I get the bottom, which is 35. So here, this gives me 18. So I end up with 18 out of 35, right? So now, again, this doesn't reduce, but if you're not sure, you can go back to the calculator. Let's go back. So this is 18, because 3 times 6 is 18. All right, let me show you that. This is 3 times 6 over 7 choose 3 is 35, remember? So we get that. And we get 0.5143. And if I take this and convert it to a fraction, you're going to get okay, it didn't convert that, probably because I have it set to 4 decimal places. If I change modes, it will probably do it. But this is 18 out of 35.5143. So now this is equal to, put it in the box for you here. So this is equal to 0.5143, which is equal to 51.43%. And that's how we do that. That's how that problem is completed. I'm going to sneak over just a tad. There we go. And that's how we do that problem, folks. Let me take you back one more time to the answer key here. And we can see that 18 of 35 was our answer. So I hope you enjoyed this video. I hope that it helped you and that you learned something from it. And I will see you in my next video. Thank you so much. Bye for now.